Hey everybody, it's Mr. Sheline here, coming at you with Unit 3.2 Part 1 notes. Before I get into the notes right here, let me just first apologize for everybody who loves or hates when I have to list the unit section and then the part we're on. I'm sure that's going to be confusing. This was a change that I made from last year, that I have like 4 separate different 3.2 notes, and a lot of students had difficulties knowing which one we started with, which one we ended with. So to make sure that you guys know where we started and then where we ended, that's why you have like these, part 1s up at the top to help you know, oh, well, 3.2, well, we started with this one, ended with this one, here's, all the other ones in the middle and their sequences. So anyway, let's just get straight to it. So ions overview. So remember, we've already gone over these two before. We've got cations and we've got anions. Cations, remember, these are the atoms that have lost electrons. These have a positive charge to them. And we know it's positive because, remember, one, we already know what cations are, but also remember the whole, like, positive, ha 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 ha, cats, kitty cats, and a meow, 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 and a meow, meow, meow. Am I right? I don't know. But we know that because of our little kitty cats. Okay, I've got my little fat chunker up here. Remember, this guy is associated with this. Okay, cations. Anions are the mad ones. They have a negative charge to them. They're the ones that gained electrons. So just a quick overview on that. Now, what we're going to be getting into is we're going to be getting into monatomic ionic formula creation. And in order to start creating these guys, we have to know what monoatomic means. Monatomic, I should say. Monatomic, ooh, and I just realized I misspelled this up here. Monatomic ions are an ion created from only one type of atom or element. Okay, and we have to understand that because we're going to be getting into monatomic ions and polyatomic ions. So more or less what this is referring to, monatomic just means this. Monatomic means like this. Our sodium plus our chlorine, mono meaning one. We've got one element here, one element here. Okay, because we're going to be getting into stuff later on with polyatomics where you have something that may look like this, where you've got carbon and you've got oxygen, but then it's being bonded with, I don't know, just off, this isn't one, this is just one off the top of my head, a metal, I don't know, nickel we'll say. So just keep in mind, and again, this one, I'm not saying that this is all ready to go, I'm just saying you've got a metal here and a non-metal polyatomic right here, compound, that we're going to be getting into these kinds of ions and be creating formulas with these guys. But just understand, when I'm talking about monatomic, we've got one element here, and then when we get to polyatomic, you would have one here, and then there's 2 here. Okay, so again, we'll get to that, and we'll clarify that when we get there. So ionic categories, so we're just going to take cation, anion, and smash it with monatomic. So monatomic cations, these are positively charged ions made of only one type of atom. Monatomic anions clearly have to be then the inverse, the negatively charged ions made from only still the one type of atom. Okay. So before we get into how to name these guys, how to create these formulas, let's just take a quick peek here at what I have for you right now. So I will give you guys, when it comes to these monatomic and also the polyatomic stuff, I'm going to be giving you guys all of this material. As far as cations and anions are concerned, this is what I provide for you. And not only do I provide that to you, I provide you not only that, but their charges as well. So remember, we discussed that when we're making an ionic compound, when we're going through the steps of making an ionic formula, we always start with the cation first, and then we attach the anion. Okay, so that's why I've got cations over here. Well, I have anions over here. Okay. I also, again, attribute their chemical symbols and also the valence charge that's associated with them. And as you notice over here, these are all correctly in the right order. So you'd have 2 plus, 3 plus. And then over here, same thing with our anions. So all their chemical symbols, and then their the number of electrons affected, and then how they were affected. So that's what I lay out for you on here. Before I get into the names, let's first check out the steps here. Let's first check out how to create these formulas. So remember, ionic chemical formulas have to be made first and foremost with both a cation and an anion. Okay. Also, compound must be electrically neutral. Okay, meaning total positives have to equal total negatives. Okay, we'll get to that, what that means in just a quick second here, but it has to be neutral. Okay, when we make these compounds, the negative electrons have to balance out the positive, the negative charge for one ion has to be balanced out by the positive charge of the other ion. Transition metals have Roman numerals, which tell us the charge of the cation, So there's a whole list of transition metals that I'll provide for you in the future. All you need to know for right now, maybe make a note of this, transition metals. These are metals. All you need to know, these are metals with multiple ions. So a good example, just to show you real quick, would be like copper. So copper has a different number of ions. You can have copper 3, which means that you have copper that's giving up 3 electrons. You have copper 2, and copper 2 is going to be giving up 2 electrons. So it's you have different copper with different, more or less, number of valence electrons they're willing to give up. So that's what we mean by transition metals. I'll have a more complete list for you when we get into the polyatomic materials. You just have to recognize that these transition metals, what they are, and how to properly, or what to properly do with them. Okay, so. We're going to be using what's referred to as the crisscross method to determine the ratio of atoms needed to create the chemical formula. Okay, so before we get into the crisscross method, let's just kind of take a peek at all these examples that we have here. So looks like we've got lithium and sulfur. We've got, SR. Why don't I remember what you are, SR, on the top of my head? SR is strontium. So we've got strontium and hydroxide. Okay, you don't need to know that's hydroxide just yet, but that's what we're just gonna, because we're just gonna practice the crisscross method. We've got sodium and chlorine. We've got calcium and phosphorus, magnesium oxide, and then copper 3 bromide. So I know that seems kind of spooky seeing the formula, the formula names out, and we haven't really covered that yet. Don't worry, we'll get there. All you need to know is we have to take something like this and then make it into something that looks like this. That's what we're doing here. So let's just do that. So before I do that, so we've got two examples here. We've got two examples here where we're just using the chemical symbols. We have two examples here where we're just saying take sodium, combine it with chlorine, take calcium, combine it with phosphorus. But then we've got two examples down here that have different names. So we'll be getting into the names it's either the next set of notes or the notes after that on how to name, specifically why it is and how it is that we name these guys. So all you need to know right now before we get to those notes is that when you see the IDE, IDE is how we identify ions in compounds. And these two right here have already been bonded together. Okay, they've already been bonded, and we'll be practicing in the future how to take the formula and then name the formula. Okay, again, that's in the future. So that's just breaking down the three ways that we would be seeing these guys being bonded together. And I wanted to wait on telling you about that because that's what's on the front here. So just real quick, if you're wondering why is hydrogen called a hydrogen ion here, why is magnesium called magnesium? Simply put, we just call the cation by its actual name, but then the anion, we will chop off the end of it and we put IDE. That's literally all it is. So for like chlorine, we get rid of the NE and we replace it with DE. So instead of chlorine, it's chloride. Okay. Again, we'll focus more on that in the future. I'm just warning you of why it is you're seeing something different and what it is. Okay, that's it. So now the crisscross method, and I just realized that this plus mark is supposed to be a superscript. So imagine that's actually a superscript. So what the crisscross method is it's a super duper simple method to determine the subscript, the number of atoms needed to make a particular compound neutral. So let's think of it this way. So we've got lithium and we have sulfur. Lithium has a positive charge, would have a positive charge or this lithium ion here has a positive charge of 1. Sulfur has a negative charge of 2. So in order to balance them out, we can keep the sulfur at just the one single atom of sulfur, but we would need to have 2 atoms of lithium. How do we know that? We crisscross. So we're going to circle their charges, and we're going to draw arrows crisscrossing each other like this, indicating that, okay, we just need 1 of sulfur, 2 lithium. And we rewrite it like this. We write subscript numbers to tell us how many atoms are in a particular compound. And then we have it, okay? Boom. So again, to compare this to something else, this is the same thing as like saying H2O. There are 2 hydrogen atoms in this compound, in this molecule specifically, and then 1 atom of oxygen. Okay, so that's what we just did. It's literally what we just did there. So I don't want you to keep that in these like ionic notes, but that's what we just did there. So let's try again. So strontium here has a charge of 2+. Hydroxide, which is a polyatomic ion. Hydroxide here has my goodness, why am I blanking out here? Has a charge of -1. Geez. So we're going to circle their charges, and we're going to crisscross. Okay. So again, because remember, we want these compounds to be neutrally charged. We do not want them to. We don't want one to have a positive charge or a negative charge over the other. So because hydroxide here has a charge of -1, we need more of hydroxide over strontium. So we're going to write that accordingly. Now, also, remember the order matters. We have to have our cation first, and then we write our anion. So it's going to be SR, and since it's a +2, that's all it needs. And plus, we know it's going to be left alone, but there's only going to be 1 because there's a 1 over here. And then the 2 of the strontium over here is going to go, and it's going to reflect the hydroxide. It'll look like this. Okay. Now, I put parentheses here because if we were to write this, if we were to write it like this, that's wrong. That's now saying that there's 1 of strontium, 1 of oxygen, and then 2 hydrogen. when no, it's supposed to be 2 oxygen and then 2 hydrogen. Okay. So that's why we put the parentheses. And you don't need to know that because realistically speaking, well, actually you are going to need to know that because that's what you're going to have to practice on the crisscross, like the big grid crisscross worksheet that you're going to be completing tomorrow. For A days, that's going to be on Friday. For B days, that's on Monday. Okay. So you do need to know that. Okay. So, all right. I hope you're with me so far. So far, I hope you're with me. Okay. Oh boy, I'm trying to think if there's any way that I've talked about this that may be too confusing, but I don't think so. If you still are hung up on this, guys, please make sure you get a hold of me. Talk to me on Remind, shoot me something on email. I'm actually going to close up so you have a better, you can see this a little bit better. Okay, so sodium and chlorine. So how, okay, so now we're just given the names. Now we need to figure out how it is that we've got to write these down and more or less bond them together. So what you need to do is we're just going to write down their chemical symbols. Okay, their chemical symbols are going to be sodium and chlorine. So just Na and Cl. Okay, next what we have to do, we need to either look at the periodic table and to see what their charge would be, or we can just look here on our list. So we need to look for sodium. So sodium would have a sodium ion would have just a single positive. So just a positive or a 1, it'd be 1 positive. And then chlorine is also a 1 negative. So a 1 negative. Okay. We circle their charges, crisscross them, and then rewrite it. NaCl. So if you notice that if they have just one, like if there's only one atom, we don't write 1. We just keep it bare. We keep it blank. It only matters if there's more than 1. Okay, just like up here with this hydroxide, just like up here with this lithium. Okay, there's 2 lithium, there's 2 hydroxide here. Okay. So let's try again. Let's do with calcium. So calcium is Ca, phosphorus is P. Let's see what calcium is. So calcium is going to be 2 plus, and then phosphorus is going to be 3 negative. So 2 plus, 3 negative. So circle the charges, crisscross. And so then we'll have Ca, 3, subscript 3, P, 2. Okay. Because again, we are trying to make neutrally charged compounds. Neutrally charged compounds. Okay. Okay. Now think of it this way. Now if you're wondering, well, how does this work, Mr. Sheline? How does this work? Okay, let's just, off to the side, let's just quickly do a little math thing here. So if we know that calcium has a positive charge of 2, phosphorus has a negative charge of 3, and we need to balance them out. Well, let's just count. Let's see what the charge would be. The positive charge would be if we had 3 calciums. Okay, just add their charges together, so that would be 6 plus. And then let's do the same thing over here with phosphorus. But phosphorus has 2 instead of 3. Okay, and then we're going to add their charges up. So 3 plus 3 is 6 negative. And then we would see then, look, 6 positive, 6 negative. That would be a 0 net charge. Okay. So if you're wondering, this is right here is explaining how it is that I know that this is equal, that this is a neutrally charged compound. Okay. It's because if we know that when we do the crisscross, just add up the charges, and you can see 6 plus, add up the charges, 6 negative, 6 plus, 6 negative, that's 0. Balances out. Okay. Now let's take a look at magnesium oxide. Now magnesium, because it's named magnesium, easy enough, Mg. Oxide though, maybe some of you already know, maybe because just by kind of guessing, but let's see what's named oxide over here. Oxide, oxide, oxide. Aha! Looks like oxygen is named oxide. So it's going to be oxygen, 2 negative. And let's just see what magnesium is over here. Magnesium is going to be 2 positive. So 2 positive, and then my oxide is 2 negative. Circle them. Crisscross. And then freeze. Everybody clap your hands. We're done with this one. Okay. So now what do we do with transition metals? Transition metals, copper 3 bromide. So copper 3. So remember, real quick, think back, who goes first when we're naming these ionic compounds? It's the cations, Mr. Sheeline. Yeah, the cations, that's right. So the cations go first, anions go second. So because we know that the cations go first, that means that this copper has to be positive. So the Cu for copper, okay, and it's 3. So when it's 3, that means it's going to be 3 positive, okay. Because again, I know it's 3 positive because I can see the 3, or it's this Roman numeral 3 up here. Okay, so the Roman numeral tells me the ionic charge. Okay. Again, the Roman numerals tell me the ionic charge. And then because it's a cation, it's a positive charge. Okay. So anyway, bromide. Let's look on the other side. What is bromide? So we're going to look through bromide right up there. So bromide is just bromine, and it has a charge of -1. So Br, 1 negative. We're going to circle them, crisscross. So then what we're left with is Cu, Br3. We have our answer. Boom. Okay. Now again, just so I can clarify, like in problems in the future, you're going to see this. Oop, you're going to see copper and then 2. Okay, you're going to see something like this. You'll see copper 2. And if what that would mean then is that you would have copper and then 2 plus. Okay. Another one, I can't think of another one off the top of my head without looking at my list. Because there are some exceptions. There are some transition metals that actually don't have a different number of ions. So I don't want to give you guys the wrong ones because I don't have the list with me right here, right now. But we'll get to that in the future. So this is what you're going to be practicing, like this crisscross method over here. This is what you're going to be practicing for me today on Thursday for A-Day students, tomorrow on Friday for A-Day students, but then Friday for B-Day students, and then Monday for B-Day students. Okay. So that is, those are the notes. If you still have any questions concerning any of these notes, guys, make sure you ask me anything, please. Because we're going to start chugging along and we're going to start piling all kinds of different stuff on, and if there's something you don't understand, you're going to be behind, and I don't want you behind. So make sure you ask those questions, get to me, so that we can keep on chugging. Okie doke. All right, I'll see you all in the next one.